Hi everyone, myself Syed Imdad Ali. I am a maths faculty. I have 3 years of teaching experience in GE Mains and more than 5 years in teaching KSET, MSET and PUC level. Today I am going to explain about ITF, nothing but inverse trigonometric function. Inverse trigonometric functions. To understand this concept, a student must know about function first. So, let me explain briefly. F is a function from A to B if every element of A have unique image in B. The function inverse will exist, the inverse of the function will exist if the function is bijective, nothing but it should be 1 1 and onto. So, 1 1 in the sense every element in the A should contain distinct element in B as an image. Onto means the range of the codomain should be equal. If the function is 1 1 and onto, then only inverse exists. So, coming to the trigonometric ratios like sin x, cos x, tan x and their reciprocals cosecant x, secant x, cot x, all are periodics. Periodic in the sense the same values after certain period the same values repeated. Again the same value repeated. So, when the values are repeated, for example, sin of n pi, sin of pi, 2 pi, 3 pi, minus pi. So, n pi, n is an integer, is will give the same output 0. Then it is not a 1 to 1, it is a many to 1 function. If the function is many to 1, inverse not exist. To avoid this, we have to restrict the domains of the trigonometric functions to get the inverse. So, for example, sin x, y is equal to sin x. If you draw the graph, we know that sine graph is something like this. It oscillates between 1 and minus 1 in the range of minus 1 and plus 1, and at pi by 2 maximum value and at minus pi by 2 minimum value. Again after 2 pi plus, again here will get 1, again here will get 1, like that values will be repeatedly occur in the function. So, when the values are repeatedly occur, it is not 1 to 1. For that to understand more easily, if you draw the line, see for the same value of x, for the different values of x, we are getting the same value for y. So, it is not 1 to 1. To get a inverse of the sin x, cos x, tan x, any function, we have to restrict their domain. For example, from here to here, this curve, these values again repeat here, again they are repeat. So, we consider the graph from minus pi by 2 to pi by 2. We restrict the domain of the sin x. Actually, the sin x domain is R and range is minus 1 to 1 closed interval. So, instead of R in the x axis, we restricted minus pi by 2 to pi by 2, so that it will be invertible. Sin x function domain is R, all real numbers, range is minus 1 to 1. So, instead of R, the domain should be minus pi by 2 to pi by 2, or pi by 2 to 3 pi by 2 also we can consider, or here minus 3 pi by 2 to minus pi by 2 also. These all intervals will give the inverse of the sin x exist here, but this is called principal range. So, sin x domain instead of R, I will consider minus pi by 2 to pi by 2, then the range is minus 1 to 1. Now, this function is invertible, I will get the inverse of this, y is equal to sin inverse of x. Now, domain and range will interchange. So, domain is minus 1 to 1, range is minus pi by 2 to pi by 2. So, this is the inverse of the sin x. So, the domain is minus 1 to 1 and range is minus pi by 2 to pi by 2. This is called principal range. In the similarly, we can write for cos inverse x also. So, in cos inverse x, we know that the cos function, it will be like this. So, at the 0 it have plus 1, right, like that is oscillate 0, pi by 2, pi. So, here minus 1. So, we have to restrict the domain of the cos x from 0 to pi, closed interval 0 to pi, then the function is bijective, then its inverse exists. So, inverse of the cos inverse, so inverse of the cos, and cos range also minus 1 to plus 1. So, domain is minus 1 to 1 and range will become 0 to pi.